So hello everyone. Welcome to our workshop 3, Intro to R and Data Visualization. And so I'm really happy you guys are here to join me with the journey for learning how to use R and how to apply R into several data analysis tasks like data wrangling and data visualization. So I'm Wenbin Guo. I'm a final year PhD student in bioinformatics IDP. So I was teaching ggplot2, advanced data visualization with ggplot2 in the last quarter. And so basically the previous lecture with Dr. Daniel Hart, but he is unfortunately out of the country at this moment. So I have to take on his job and then teach this Intro to R workshop. So, but since I have been using R for let me calculate how many years, maybe 7 or more years. So I think it's a pretty good time to maybe teach some kind of R, and because I use it for almost all my research projects, I think the R is kind of powerful in terms of handling the analytics. So this workshop, so basically I sent the slides to you guys just before we started. And then if you haven't received it, maybe wait a couple of minutes. And if you still don't receive it, send me an email, I will send it to you. So basically here is the notation of the slides. If you see arrow here, basically that means it's a code chunk or the pseudocode chunk. And basically you can just copy the whole text into your R console to run the code. And then the link is underlined, and some important terminology is in the bold font. If you see this little yellow man, usually it means this slide is a practice slide. We're going to stop the recording for a while, give you maybe 2 or 3 minutes so that you can focus on working with the little challenges there. So for the workshop goals, our goal is apparently try to master the basics of R programming and also use R data science toolbox, specifically called the tidyverse for data wrangling. And also lastly, after we finish all the coding, data cleaning, and also finishing the modeling part, we want to present and also report the results with the R data visualization toolkit, the ggplot2, which is a very powerful data visualization toolkit. So basically, our major goal is trying to get you guys familiar with R and R programming. Basically, we are going to use the RStudio, which is a very convenient and also very useful IDE to write everything. And I hope that after this workshop, you guys can put your skill set on your resume. Like you say, oh, I'm very experienced in using R. So hopefully we can reach that point. So this is our agenda. Basically, in day 1, we are going to learn the basics, syntax, and the grammar of using R. Specifically, we will set up the environment for scientific computing in the R environment. And we're going to learn some variables, operators, data structures in R. So basically, those are really basic essentials of R. And those are like building blocks. If you want to build like a very tall building, you need to have a very solid foundation at your root. So basically, this is how we are going to build our foundations. So besides that, we are going to learn how to control the flow, the logic flow, and also how to use some loops to iterate through some kind of vectors or list or data frames, etc. And in day 2, we are going to learn some advanced topics. Specifically, we are going to learn the functions, the file input and output, how we read the file into our R memory, and how output the results into another file. We're also going to learn the data wrangling using the dplyr, tidyr, or the table. So basically, those are really advanced data science packages, and many of the statisticians or data scientists they use it heavily. So we're going to learn some usage of that. And for the day 2, I also plan to talk about some statistical tests and models, because from the roster I got, I know some of you guys are from the pure biology background. So basically in your daily life, probably you're going to do a lot of statistical tests, try to give some kind of a small p-values for your hypothesis. So I want to talk a little bit about the statistical test and talk about the rationales behind. So on the day 3, it's mainly about the data visualization with the ggplot2. So basically, if you read the most recent literature or everything, you probably will see a lot of those figures are ggplot2 figures. So ggplot2 is a very powerful tool to make the publication-ready figures. But honestly, I think because that whole topic is actually deserves one whole workshop, 3-day workshop. We're not going to learn everything in just 1 day. So I will just try to fill in as much information as possible, introducing the syntax, grammar, and the elements behind. And I also try to make those basic plots like scatter plot, histogram, density plot, etc., and teach you how to customize the plot towards your desire, etc. So here, this cartoon actually shows what we are going to do. So basically, I think after the workshop, we can reach to the second level, second step. And if you want to learn more about that, you should read the documentation, read the references, read everything to become really strong. But at least for this workshop, I think we can confidently reach to the second point if you follow the slides pretty well. So here are the references I listed here. Basically, in the day 1, it's mainly based on this learning R book. And the day 2, because we are going to learn the advanced data wrangling using R, so it's a second book. And the day 3 is mainly about the data visualization, so it's a third book. So here, if you click the link, you will find the website. And basically, if you are a UCL student, you have access to UCL library. You can have a free access to every book. So this is pretty good for us. And some of the books are open source books. So basically, if you are not connected to UCLA VPN or campus network, you can still access them. So it's really a exciting time for us that we don't really need to buy anything. We don't need to go to the library to borrow the books. Just sitting at home, drinking some coffee, and then learning art. So basically, that's how the whole field looks like. So I also listed some useful references. For example, the advanced R. It's a very advanced or more intermediate level for the users, more at intermediate levels. R in Action is another good book. It has a lot of statistical modeling, like for example, how to run the ANOVA for analysis of variance. Introduction to Data Science is a new book. So the author is a professor at Harvard Biostats department, and I think he recently devoted a lot of his energy into the education and even pushing this book to the market. And the R graphic cookbook is like a recipe. So basically, if you have a plot in mind, you can always try to check out this book and then find the demo code. From the demo code, you can adjust. You don't need to write everything from the beginning, from the scratch. You adjust, modify those code to use them. So basically, those are really good references. I highly recommend it. If you have time, you can check them out. And honestly, if you finish the first 3 books, then you definitely will be better than me. So you can actually, maybe for the next year, you teach the same workshop as I did this year. So for the before we go into the environmental setup, I want to do a quick survey. So basically, I wonder, like, your guys' background, like how many of you guys have used R before? Please raise up your hand. 1, 2, 3, 4. Not so many. Okay. And how many of you guys have any programming experience before, like no matter what language, Python, everything? 1, 2, 3, 4, 5. That's very good. So basically, at least half of us have those programming. If you don't have those background, don't worry, because we are not going to be very intimating. Like we are going to be as considerate as possible. So the very first thing we want to do with the workshop is try to set up the environment. So basically, I don't know if you guys have R installed. If you don't have that, you can go to the official download website. Just click the link here, and you will see this web page. It's a posit.co. So basically, they used to have the name. The company is named as RStudio, but since they have a very good time with the revenue, they make some money. So they want to push everything to the next level. So they renamed the company to call that Posit. So basically, the very first thing you need to do is to install the software, install R. Just click this link, and then you will enter into this page. It's R it's an official R website page, and based on your operating system version, if you are a Windows user, click this download R for Windows, and then try to install the base R. Just click everything per prompts. And if you are a Mac OS or Linux user, you can just try to select the one that suits your computer version, download the different package according to your computer chips. And since I already have downloaded it before, so basically I will just skip it for now. But I think it's pretty straightforward. You can download, and then after you download, you can install. After installing, you can just go back to the previous page, which this one. So after you finish installing R, you can try to download the RStudio desktop. So it's a free version, RStudio IDE. Again, like when you finish downloading, you can install it. And after you finish, you can let me know. Maybe I can give you guys 3 to 4 minutes to let you finish everything. And in the meanwhile, if you have any questions, please raise up your hand. I will come to you and try to provide some help. So I guess the downloading and the installation is quite easy. Shouldn't have any issues. If you do have issues in your future, remember to Google. So basically, every issues you have probably is already solved by other people. So Google is a good thing. So now let's dive into our day 1 workshop. It's mainly about the R basics. So this is a 3-hour workshop. As you know that I cannot talk for the continuous 3 hours. And trust me, it will kill you. So basically, we are going to have a 15-minute break every 45 minutes. And in the last session, we're going to have a 30 minutes lecture. And the rest of the time is the practice and the Q&A. So basically, hopefully, we should be able to finish before 12 o'clock. And for the topics, first I want to give some brief introduction about the R and RStudio. Basically, what's that, and also why do we need to learn it? And then we are going to dive into the details about our programming, specifically the variables, operators, vector matrix list, so those kind of containers that can host our data. And then we are going to learn the flow control, specifically the if, else, etc. If you have already programmed before, you know those kind of a conditional statement. Basically, those are pretty useful when we want to write a very complicated programs, and also the loops. And lastly, we are going to talk a little bit about the packages. Specifically, there are maybe 20,000 of packages over there right now in the CRAN. And also there are a lot more in the GitHub or the bioconductor. Basically, we are going to use some of them in our daily life, in your own research. So basically, you don't need to reinvent the wheels. You just standing on the shoulder of the giants. So you can see further away, right? This is, I think Isaac Newton said such kind of things before. So basically, we are going to use those packages. And we are going to also do see some examples and also do some practice. Hopefully, from the day one workshop, you learn some practical skills and can use it in your later research or your later life. So here is a brief history of the R language. Basically, we can see there are several milestones. And the very first milestone is actually 50 years ago. And some of the statisticians, the John Chambers and the Trevor Hastings, those are two famous statisticians. They try to use the computers to do some statistics. So basically, you know, like statistics in the original field is about computing, like how we can use the computing and how to get some kind of insights from the data. So they involve a lot of computation, and especially after the 20th century, the modern statistics, they heavily rely on the computing. So these two need a team, and they develop a language like S. But basically, this language is kind of dead right now. It's too old. But later, these two gentlemen, the Ross and also the Robert gentlemen, they try to use the same idea or try to adopt the legacy of S language and then invent the R. So have you ever thought about why R is called R? Any idea? So basically, these two gentlemen, their first name starts with R. So this is the one. Okay, so this is a small fun story that you can tell your grandma, saying, "Okay, I know a new language called R, and do you know how R comes from?" I actually know something about that. So this is something you can talk to your outsider friends or family members. They probably don't know how to program, but they will be happy to hear some little stories during your learning journey. So this R is invented actually pretty long time ago, but along the time there are several updates and also several milestones. For example, in the early 2000, the R 1.1 it's the first release, and 20 years later, it's R version 4. So basically, right now the R you installed is 4.3.3. So basically, it's the version 4. And after these two gentlemen, actually, there is another guy called Hadley Wickham. So this guy actually initiated the tidyverse. So this is the most famous guy. And in the RStudio, there are a core team consisting a small group of intelligent people. They try to make the data analysis pretty easy, pretty handy. So they initiate this tidyverse project. it contains a series of R packages, and basically using those R packages, you can do some modeling from all the aspects you can think of in data science projects. This Hadley Wickham is also the author in the previous reference books like ggplot2. Actually, this guy is a creator, and in some like R for data science, and also the advanced R, those two reference books, he is actually the author. So actually in 2019, I think the highest award in statistics, the COPS President Award is given to this gentleman. So people are very shocked at the time because statistics usually those highest award are given to the researcher scientists who work on the theory. Nobody wants to give it to some kind of application guy who just develop software and then make some fancy plus. But at that time, they recognize the contribution of Hadley Wickham and then give the award. So people just shocked, but they think, okay, he really deserves the award. All right. So this is a brief history, how it comes from, like who invented it, and what's the current stage of R. Basically, what you should know about R is that this language's main focus is about data science and statistics, and also it's has a very supportive community, and they have a lot of packages over there. It can be used in many applications, like making graphics, making the web apps, making the interactive portals, and but there are also some kind of pros and cons about R. For example, as we know, their focus is data sciences and statistics. So they excel at those statistical analysis and the data visualization. They have a rich package ecosystem. They got a very good community. They can be very flexible and extensibility. So basically, you can consider when you need to do some new analysis, you simply can create new packages, and using those new packages, adopt it to a particular task. So it's also very useful for reproducible research. I think in statistics, people are really love the reproducible research recently because we think many of the biological experiment or even the biological papers, they probably cannot replicate what they have found. So this one is kind of getting more and more attention right now. And because R is open source software, it's cost-effective solutions. You can find those resources, learning materials very, very easily. Basically, you only need to have the only requirement is you have access to internet. And it's also under active development, but also R has some kind of disadvantages. For example, learning R is not so easy compared to Python. It has a steeper learning curve, meaning you probably need to spend more time to really get comfortable with R programming, especially when you are working with vectors, like vectorization. You probably need to have some kind of sense, matrix algebra sense. And also because R is a high-level language compared to C and C++, those kind of lower-end language, the performance is kind of limited. So you don't really want to use R when you are in face of really heavy computing. So basically, the speed of R is a concern really. And the memory management is also an issue that it doesn't really allow you to manage memory that well, and the data security is another concern. And because of the R's focus, it's data science, statistics, they don't really have that much of support for doing the object-oriented programming. So unlike Java or JavaScript, those you can actually use those language to make an app. But R using those language to make using R to make an app is kind of a bad idea because it doesn't really give you that kind of flexibility. And the limited GUI options, again, it's not like you're using your iPhone, you have an app on that. So R probably it's not good at that. And also sometimes R didn't give you very meaningful error messages. So the debugging is also a challenge. But definitely, I think everything, they must have some kind of pros. In the meanwhile, they have some cons, but what you really need from this thing is just trying to take the advantage of it. So just like when you are facing other demands, you just don't care about R anymore. Just using the statistics and the data science part is fine. So R is also a very popular data science language. So basically here is actually the left panel is the popularity rank on the GitHub by the number of projects. And the y-axis is the popularity rank on the Stack Overflow. The GitHub is a project repository, and Stack Overflow is it's actually like a forum that people ask questions on there. So you can actually see for the data science language, R is actually pretty good, standing at a pretty good position. Although it's kind of inferior to Python, but like Python is so it's so hot right now. So R is actually kind of in a good standing, I would say. And on the other hand, you can see that the blue line is R. So basically, it's steadily increasing to some point. And I actually don't really know what's going on here, like why Python drops a lot and also other languages drops a lot, and guess. Like why people are stop asking questions on Stack Overflow. Yeah, exactly. So basically, this is actually the time when ChatGPT is coming to pushing it to the whole world. So people stop going to a Stack Overflow asking questions; they ask ChatGPT. So I think that's probably the case. And I guess if ChatGPT can collect the user data and then try to also plot the popularity of different languages, you will also find the same tendency that Python probably will be the top one, and R will be the second one among the data science languages. Again, like R is kind of popular and it's steadily increasing. So the reason why we naming R is actually Weissman once said, I think, therefore I are. The real reason is actually what we have mentioned before. It's pros of those R. So here I'm not going to repeat myself, but basically you can see that a lot of packages, strong package ecosystem, a lot of packages you can use, and it's really useful in research. For example, when there is a COVID-19 and you want to collect the data and make it into a interactive portal, so you can just open the web page and use your mouse to click and see the data. So R is pretty good at it. So it's called the R Shiny app. And if you are working with single cell genomics or using working in any field related to genomics, you probably see a lot of figures like this, which is a single cell data set, and using the SURAT package, and SURAT is actually a package in the R field. And also the R has a wide application in both academia and the industry, including even the FDA and many of the pharmaceutical companies and many other tech companies. So actually, I heard about some of the pharmaceutical companies are switching from SAS to R in some way. Like SAS, when when there is a new drug pushed into the job market, we need to go to some kind of investigation under the FDA regulation. So the recommended software for statistical analysis is SAS. So basically, it's a kind of like a routine. But right now, I think there is a small transition, trying to getting more and more attention with R and using R to finish all the statistical analysis there. But again, like if you know R, you probably can find a good job in those companies. Hopefully, in the data science with R, will always have more job openings, despite of the ChatGPT. Anyway, if you are going to learn R, you must experience this kind of a phenomenon. There is always a debate, which language is the best language. And so everybody should stop using certain language, and everybody should using this language right now. So I think there is always a competition between R and Python. You know, like Python is so much kind of a generic programming language. It can finish a lot of general purpose programming from the data analysis using NumPy kind of, or if you are specifically if you are working with the machine learning, deep learning. So Python has a very good community there, like PyTorch, TensorFlow, Keras, and even the scikit-learn. So basically, there is always some kind of pros and cons for every language. And there is also some kind of a statistic showing that 90% of the Python users, they remain loyal to Python. And around 75% users remain loyal to R. So I guess these people probably will be statistician people and maybe some biologists, I guess. But there is a small fraction of a transition going on. So I think usually like arguing which language is the best language is meaningless. Usually we only care about the strengths of different language. So for example, if you are working with data science, you work with data cleansing, you probably can just use R for those tasks. And if you are really in need of machine learning, deep learning, you can try to use the Python to do that. So basically, you really don't want to use R when you need to build a neural network, train a neural network. R might be a nightmare for you. But in the meanwhile, if you are working with the statistics, then Python is kind of sometimes kind of a headache. So instead of trying to argue which one is the best, so here I would suggest try to learn both of them, take the advantage for both of them, and then you probably can achieve way much better than just mastering one of them. So that's everything about the advantage, disadvantage, the current status. So if we are going to learn R, we will need to have a computing environment and also a good interface. So a good thing about R is that we have this very common RStudio IDE. So compared to Python, probably you can use Jupyter Notebook, you can use PyCharm, VS Code, so much kind of choice for you. But R, we have a very uniform choice, RStudio IDE. So basically, everything, or like basically 70%, 80% of people just stick to this one software. So they use it all the time. So the IDE stands for the Integrated Developmental Environment. So if you open that RStudio, which you installed just now, you probably will see these 4 panels. In the top left panel is the source panel, which includes a source file, the R file. And on the left bottom, you will see this console or terminal or jobs. So basically those are where you can just put in commands, and then let the computer finish programming or finish computing. Besides that, you have this environment and history. Environment will record what variables in your environment, what functions, what kind of data in your environment, and the history records what lines of code has been executed. So besides that, you will see this file, this bottom right files plus packages helping the viewer. So I really like this part that you can, when you write the code here and run it from here, you will see the results from here. So basically, this is very, very convenient for us, and specifically for this help page, I think it's maybe my favorite part compared to Python, that you don't really need to open another web page. If you don't know anything, just go to the help page and check the documentation there. So it's really convenient to use. So I guess you guys can just open the RStudio you started and see the interface here. Again, like this is the source panel. This is the console panel. It has several tabs. So this console is a tab for RStudio only. For example, you can try to do some random, use it as a scientific calculator, do some calculation from here. And also it has a terminal. So basically this terminal is exactly pretty much the same terminal as you used in your intro to Unix command line workshop. So this is like you can run the shell script from here, or you can run the some kind of Python script or the R script. So basically, it's just a command line interface. And this background jobs is another panel, but usually we don't use it that much. So basically, if you are going to render something, for example, from a R Markdown file to a PDF file, so basically you will see those background jobs here. We don't really use that much here. And from the files, you can go from one folder to another folder just click on your mouse. And from the plot, in our day 3, we probably will use it a lot. When we finish running the code, it will generate a plot for us, and this plot can be really informative. Like when we modify something, we want something, we can get the instant feedback. And the packages denotes what kind of packages you have installed. And if you want to install more, simply click this install button. And then, for example, if you haven't, you can try install tidyverse, and then just click the install. So basically, it will finish everything for you. And the update is trying to do the project, the package update for you. And the help page, as I said, is pretty useful for documentations. Specifically, as a human, I'm pretty lazy, and I don't really want to remember everything. If I don't know anything, I just try to go to the help page, type in whatever topics I want to search for. For example, let me see how to calculate the mean of a vector. So we just type in the mean, and then it has the usage, and it has a very detailed documentation. Okay, what the program is supposed to expect from the input, and what's the meaning of some kind of arguments, and what's the output, expected output. And more importantly, it also provides some examples. So those examples you can simply copy and run from the console. So after running it, you will see the maybe see similar results. So the review and the presentation mode are for other users. We are not going to really touch it in our learning this workshop. And for the top top right panel, as I mentioned, that the environment records what kind of variables there, and the history records what kind of code you have run from the interface. So here, because I previously used it for a lot of ggplot plotting, so you can basically see the history, like what I have run before. So there is also a table collection. I never used it before, and right now I still have no idea what it's about. So if you find out, please do let me know. So lastly, for the source panel, usually we just use it to create a new file. For example, let me try to exit from the mode. So basically, you will see this drop-down menu. You can create a new file. For example, RScript. In this RScript, entitled 1, you can write down the R code. For example, you just simply assign a value to a variable, or simply just print some print a string. So basically, just as a tradition of every programming language, that our first cry to the R word is printing a hello world. So basically, I think it's a common tradition for any other programming language. You can try to run it from your own terminal. And besides the R file, R script, which will end up, sorry, it's not responding right now. Oh, okay. So basically, it has ending as a pointer.r. So this is a typical R source file. So besides this one, you can also create other files like R Markdown. If you use Markdown, if you are familiar with Markdown syntax and you try to use it for documentation, I would suggest this one. And also there are some other file type you can create, like the ordinary text file. For example, you want to write a README file. If you want to use RCPP, you can try to create a C++ file. And actually, the RStudio can be used to write a Python script. So I think it's a kind of annoying for the Python users, because you are actually taking the territory of Jupyter Notebook or anything. You use the R language environment to write the Python code. That's like yeah, that's kind of funny. So besides that, you will see other buttons. Basically, you can just go over your mouse to see the meaning of each button, and also there always shortcut key. For example, here it's a command line, command and S, which will save the current document into your local files. So besides that, you will see the drop-down menu from the top. Like for the file, you can also create a new file from the new file here. And when you finish everything, you can quit sessions. This will terminate the RStudio. And besides that, you can also save the file from here. It's pretty easy. And another thing I want to mention is about the tools. There is a global option, so you can try to click it. Let's see. So it will pop up a window for you to customize a lot of things. Sometimes you want to have a different appearance, like a different color style for your code for your RStudio IDE. And sometimes you want to have different settings for how to display your code. Like for example, here using rainbow parentheses, it's what I really like. That when you have a lot of parentheses clustered together, it actually shows different color for the nested parentheses. And there is also a Copilot part. I think I highly recommend using it. So if you have the Google GitHub or Copilot, so actually it will prompt the possible R code you want to write. So you don't really need to write everything. It will automatically give you some hints. And what you need to do is press a tab key and then auto complete everything for you. So I use it to write several code, especially when you are dealing with the very repetitive work. So you are writing the same code, just modifying some parts of your code. So I think this can save you a lot of time and efforts. And by the way, if you are a student, then you can get the Copilot for free. So this is a good message for our students, right? Okay, I guess that's a basic introduction for the RStudio IDE. And we are going to have a 10-minute break. After that, we will go back to learn the basic R. So, okay, so just a very brief introduction about the RStudio IDE. So I guess we are kind of familiar with the panel, different 4 panels of RStudio, and later we are going to use it to write our own code. So basically here, we actually just demonstrate like how to open the RStudio interface, how to print a hello world. And the last thing is how to exit from the RStudio. So basically here, we actually can just click the close tab on the top left. We can also put the command line Q, which means quit with parentheses, meaning this is a function. So after that, you will see a message will pop up saying whether you want to save the change, etc. So this is just a small demo. I don't really want to close it, so I can say it. But I think you guys can try on your own. So again, like because we have so many commands, we have so many functions in RStudio, so we are not guaranteed to remember everything. And especially there are so many parameters, so many arguments within the functions. We don't really need to remember anything. So just if you want to get some help, like get some hint about the documentations, you can put one question mark with the function name or the data set name. Then if you already know the name of the functions, and if you don't really know about the names, you can put 2 question marks, like you are double questioning something. So you are going to search for the topic. It's a more general search. And if you run it on your own computer, you actually find the very first one. The first one will be very fast, but the second one will take a while to finish the computing. So basically here, as I just demonstrated previously, if I just use the question mark with min, you will see the page pop up in the help panel. And if you are going to put a 2 question mark with min, you will see there is a significant, not really significant, but kind of a long time to get you the results that has a min as a topic. So there are so many packages I have installed, and they probably have their own min functions, or some of the functions that ends with min will have min in the middle. So you can also use the help function or the help search function, which is very similar to the question mark and the double question mark respectively. And if you only partially remember a function's name, you can use this propose keyword. If you just remember like the last not the word of the function. Like, for example, it's a k-means function, but you only remember the means. So you can actually put the word inside this double quotation and then put it in this function. So here is just like a small example. You can, following this code, you can try it on your end and see what the results will be. And here I show another example about the propose with a vector as the argument. And so basically everything it will pop out is about the functions of vector and also a variable I created that contains a vector in the name. So here you will also find that we have this special line that starts with a pound or hashtag. So this is actually called the comment. So the hashtag, if it starts, then the following till the end of the line will be regarded as a comment. So the when R runs the code, it will not interpret this part, it just ignore this rest of the lines. So it's pretty useful for some kind of a code documentation, because sometimes, you know, when you I think from my personal experience, there was a time that I have a brilliant idea at the middle of the night, and then I wrote the code. I feel very excited about that. And the very next morning, when I woke up, I cannot remember, I cannot understand, I cannot remember what I have wrote. It works, but somehow I just don't understand the logic behind. So this is a very good cases that you can actually use the comments to write some key steps, write some hints in case you forget about everything. And usually when you need to share the code with other people, probably other people don't really know your style or know your conventions for writing the code. So it's also very, this comment is also very useful for communications. So here, it's like another opposite example that I put a print hello R and I put the comments here. So because this lines of code is so simple, basically you can write it. So really, you don't really need this comment line. So too much comments and the too less comments are the two extremes. You don't really want to, you really want to have something in between, like you have a balance. Not saying too much, but you see something necessary to help you understand. And here is the question. So basically here, that a pound will just start a comment, and till the end of the line, it will be ignored. So what if you have multiple lines that you want to comment? Like for example, you have multiple lines of code that you want to ignore, and then don't make them run. So any ideas like how to comment the multi-lines? So in Python, you can use 3 quotations, right? 3 double quotations or single quotations, and write everything in between like a document. In R, how to do that? Yeah. So it's just a very simple, just put a hashtag at the front of every line. So it's kind of not so elegant, but it's a way to solve the problem. So, but you don't really need to type in the pound symbol every line. You just select, for example, here. Here you select word lines, and then you, if you are using Mac, you can use the Shift and the Command, and with letter C. C stands for comment, the first letter of comment. And if you want to uncomment the whole thing, you still select everything, Shift, Command, and C to uncomment everything. So it's just like how to save some trouble about commenting. You don't really need to type in everything. So if you are using Windows, just replace the command with Control. So you are basically will do the same thing. Sure. Mm-hmm. Yeah, so so basically this is just like the output. It's not really related to the code lines, etc. So it's just a symbol for the output. You can also use other symbols but yeah, basically it's not really related to the code. It's just a format of how you write up the output. Yeah. Okay, I think the very first thing after we get familiar with the basics of RStudio and also how to get help on the RStudio interface, the very first thing we will need to know is about the variables. So again, like learning those basics is kind of boring really because you're dealing with a lot of details, and maybe you don't really see what's the point of those details. But again, like understanding those is kind of like a fundamental thing, will be useful someday before you realize. So the variables, you can consider it as a container that tries to store your data. So here it's I think it's a pretty good cartoon that variables is actually can be considered as a box, and each box has a name, and it also can contain a value. So basically, the value, the name, actually they have different types. Some of them are the integer, numeric, or some in Python we call it as a float, and some of them are the chars, characters, and some of them are the strings. So basically, there are different types of variables. Each of them should be treated with a name and with a value. And so about the name, so how should we name a variable? So actually, I want to bring up your attention that we are dealing with something very difficult. So basically, this is a famous guy who wrote a book called Refactorization back in early 2000. And yeah, this book is a kind of regarded as a Bible book for many of the software engineers. He has a very good saying that there are only two hard things in computer science: catch, invalidation, and naming things. So catch invalidation is related to something about CPU, the architecture about of CPU, how it can make the computer run faster. And using programs, you probably will meet some kind of mysterious errors about the catch things. So it's very hard to do. And the next thing I think is the most difficult is naming things. Give something a name. So how hard it can be, right? You can name this thing as X, that thing as Y. But when you are dealing with a very complicated project, you will really see the difficulty of doing those namings. For example, you have different versions. How are you going to name the different version of things? You can consider using, for example, the Apple's strategy, like you name the software version as a Big Sur, right? You name it as different animals. You can do those kind of things. But yeah, those is just like one example. When you are really dealing with the naming things, you probably will. I think I have a good picture here. You are just staying there thinking, oh, what's the meaning of the life, or how I'm going to name the things so correctly. But anyways, so for the R naming rules, we actually can consider naming in this way that the variable names should contain the letters, numbers, dots, and underscores. So don't use anything else like a $sign. Don't use it. Just using these combinations, right? So this, I think, it's also like when you are choosing a password for a website, you are also trying to use these letters, symbols. And this kind of variables, they cannot start with a number because the computer program, the R interpreter, cannot recognize whether this is a number or whether this is going to be a variable name. So just avoid using the first letter as a number, and we'll just a dot followed by a number. So just avoid that. And also there are some kind of keywords, the reserved words in R. For example, the if, like a conditional statement. The for loop, like for is a keyword for the loop iterations. So basically, you should also avoid naming things like that. And there are also some kind of other naming conventions. For example, you shouldn't use the lowercase and the uppercase interchangeably. And also you shouldn't give two names, but they are just one, for example, one as a book, like when you're reading a book, you need name the other ones a collection book called the books, just one letter difference. So just try to avoid those things because it will give you a really hard time when you are trying to debug. For example, you are trying to see whether the books is doing good, but it's so hard to distinguish book and books. Only one letter difference. So just try to make things a little different and make it more meaningful for you. So this will save you time, hopefully. And if you really want to know the details about the naming rules, you can try to check the make names. It will contain some details about what is allowed and what is not allowed in the R programming. And also, I want to mention one point that the make names is quite useful for dealing with duplicated names. So especially when you are dealing with gene expression data, if you are working in the biological science field, you know, sometimes two genes, they probably share the same name. So it will give you some hard time when you try to, for example, how to, like using the gene names as row names, but duplicated row names is not allowed. For example, when you are having a matrix, duplicated row names is not allowed. So how are you going to deal with those things? So basically, this make names will automatically handle it for you. So you can just try a very simple example. For example, we name A. We have a duplicated name here, pretending they are the gene names, and we have the make names. X, and I think it's unique. So it will try to just very simple, just try to put the first duplicate with 0.1, second duplicate with 0.2, etc., etc. So it will try to make the names a little bit unique, all right? And another trick I want to mention is that when you type things, you don't really need to type everything. Simply just the RStudio has some intelligence. It will pop up some recommendations for you. Just select them, and when you are not sure about what's the output, what's the input, simply press the tab key. The tab key will give you some prompts about what's expected for this function. So this is a small detail. So we have the variable name, and we also talk about each variable has a value. So the next thing is that how should we assign the value to the variables we just named, we just created. So this is related to the value assignment. So basically, we can assign a local variable using either this. Yeah, I always like, I think it's assign and symbol, but basically it consists of smaller than, and with the minus sign. So basically it's a two sign, two symbol. Or basically you can use the equal sign. Both of them will give you the same, usually give you the same results. And because of some of the historical reasons, the former one is preferred. But under most cases, you can use them interchangeably. So basically, my preference is using this equal symbol because I feel it's more natural, and also on the other hand, I program in Python, so I'm very familiar with just one symbol. But this is just something yeah, you can know. And if you see some symbol like this, you realize it's just an assignment symbol. Okay. So there are some difference between them, but most of the case, when you are just working with your own project, you are probably don't see those special case. So most of the time you can use them interchangeably. Don't need to worry too much about the difference between them. So again, like this is a small meme that I would rather draw 25 cards in a Uno game instead of changing my habit from the equal sign to a assignment sign. And also that it should be noted that there is no space between this smaller symbol and the minus symbol. If you do that, it will try to interpret the smaller symbol as a smaller and the minus as a negative. So for example, we can do a very quick test here. If we use this assignment symbol, we assign 3 to the variable called y. And if we put a space between these two symbols, and what we will get is that for the first one, we see the assignment is successful, it's 3. For the second one, we get a false. Why it's a false? It is simply because y right now is a 3, but the right-hand side right now is -3, and the symbol here is interpreted as a smaller than. So 3 is smaller than -3. Nope. So we get a false value. So this is a very intuitive way or to understand why there shouldn't be any space between these two symbols. And also some surrounding space should be nice if you choose to use either signs. So basically here it's just for the clarity of your code and for the beauty of your code, because we really love something to be clean and tidy and beauty instead of trying to compress everything together. So some space will be perfect. So it's really like the human beings, right? We always want some our own private space or something. So this is the same philosophy in programming. And we can also do some assignment using the double smaller sign with the minus. But what is a global and what is a local variable, we are not going to teach them today. But in tomorrow's lecture, when we talk about the functions, we are going to learn what's a global variable, what's a local variable. So, but for today, I think it's just fine. You just see there are two different things. It's related to the scope of the variables, but those are kind of an advanced topic. And what can also, the third way we can do assignment is using the assign function, which is just put your variable name as the first argument, put the value as the second argument. So you can try, for example, here. Right now the y is 3, and if we assign, so remember the first one is a string. It's not a y itself. It must be a string. It's a name itself. If we assign it to be 4, and after that we print out 4, so meaning that we assigned the variable successfully. So anyway, this is the value assignment. So I think we just do the practice from the interactive session. And the second one is that it's very interesting to think. For example, here we have the 3 and 4. Those are very small numbers. So, but have you ever considered our computers is a very it's a limited machine, how it can represent all the numbers in the universe, like from the negative infinity to positive infinity. How does the number how does the number really fill into this smaller machine? So basically, the short answer is that we don't. So basically, in the R program, or in the regular Python, we usually encode the numbers into a double precision. So this it has 64 bits. Each bit contains a 0 or 1 value, and it represented in this way that we have a fraction part with 52 bit, and it has a exponential part 11 bit, and the last one is a sign part, indicating whether it's a positive number or it's a negative number, etc. So for the computer perspective, with the value we actually presented is D0, D1, D2 to the DP, which is a fraction part, and each of the D will be either 0 or 1. So it can encode this much of the numbers. And the B here is 2, because we only have 2 choices, either 0 or 1. And the E here is the number of the value of the exponential part. So again, this number is not infinity, right? It must have some kind of upper bound, lower bound, etc. So as a result, the biggest number, the double precision number can be is around this big, like 1.8 times 10 to the 308. So it's big enough, but it's not infinity. And the smallest positive number it can represent is this very small value, but it's definitely not 0. So it can be encoded as 0. And the next positive part is this small number. So that means anything between 0 and this small number is not representable by the machine. So this will have some issue we will see later that about the rounding errors. So when the number is very small, then you probably later we will see the effect. But the point I want to bring up here is that probably it's kind of like a background about understanding the following behavior about R. So again, this is not only R's problem, but also faced by other programming languages. I feel it's very essential to talk about it because I don't think you guys really, I think this part probably were not taught in any programming language or programming classes. So if you really feel curious about the properties of other numbers, like what's the maximum number it can represent in your own machine, you can put the pointer machine with the first letter capitalized to check the details, like what's the maximum number it can represent, what's the minimum number it can represent. And because R is used for statistical computing, and usually we talk about the likelihood. So likelihood is a probability, the product of probability, right? So if you have some intro to stats background, the likelihood is if it's a probability product, and then the probability is always between 0 and 1. So product will become smaller and smaller, and as you multiply more probabilities. So this will usually have some issue that it will reach to the limit very soon. So how to address this issue that you don't work with the probability itself, but you work with a log transform the probability to make it a negative value. So negative value probably will be can be handled easily by this representation. So this is why we don't really work on the likelihood. We will usually work on the log likelihood. You have any impression on that from any advanced stats class? But this is something interesting you can keep in mind. Hopefully, it will be useful in some way. So besides the number representation in the R, I also want to talk about the special numbers. Specifically, I use the infinity or negative infinity to represent these two symbols to represent the very big or very small, like infinity big or small. And the NA stands for not available. It's the missing value. And I think usually in your real data, you are going to need to handle with the missing values because the real data is really kind of noisy or really messy. So this is pretty much like a common issue. NaN means not a number. So it just says the calculation doesn't make mathematical sense to the program itself. So sometimes you probably will see those numbers in our program. So don't get panicked. You already know the meanings behind. And if you really type in the 1 divided by 0 in console, you will probably see the infinity. If you try to add a NA value to a constant or subtract, multiply or divide, you probably will also end up with the NA. So I'm not going to show the demo here, but you can try it on your own. I think it's pretty straightforward. And then there are also some other interesting numbers you can directly access from the R, like a pi, which is a value between 3.14. So you can just type in PIs and then it will give you the constant. And if you know anything about the R function, so the idea to get a natural component E, like the log, natural log E is actually pretty simple, that you can just say, it doesn't really give you E. Like if you type in E, it will regard the E as a variable name, but you don't have a variable E in your environment. So it will say object E doesn't found. What you can do is try to use exponential, and this is a natural exponential. So when you put one as the argument, it will actually returns the number of E. So it's 2.71, which is pretty close to what we expect, right? And if you are working with mathematics, probably you see this before in your high school, but never use it later on. It's called the imaginary number. When you are dealing with the complex numbers, not real numbers, you have the real part and the imaginary part. So the I is an imaginary number in R. So if you directly put I, it will still say object I is not found. What you need to do is just put a 1 before I. So this will give you the 0 plus 1i, meaning this is a complex number with the real part to be 0 and the imaginary part to be 1, right? So this is the special numbers. I don't think Python has this, probably not. So this is kind of special features for R. So besides that, we talk about the variables name, variables value. Here I also want to talk about variable class because it's kind of important topic, especially we want to assign variables. Like we want to decide what operations we can have on the variables. It really depends on the class. So you can consider we have several basic variable types, like a logical type, which is a true or false value. It's a bool value. And the numbers can be numeric, which is a floating number, integer, which means it's as the name says, just an integer. So if you want to force a value to be integer, you can put a L suffix to make the numbers as the integer. And it can be complex value, as we have just shown in the RStudio. And they can also be the character or the strings, just storing the text message. And it can be factors, storing the integer with labels. So later in the vector part, we will talk about the character and the factors in details. So what are how to access the variable classes? It's just using the class function to check. So for example, here, we can check the 1i, which means it should be a complex values. And if we class 1 L1, it will give you the numeric showing it's a floating variable. If you put a L, capital L at behind, it will say that it's an integer class. So this is how the class function can be used to check the variable types. And for inspecting the variables, I think we already did that, like how to print the values of a variable, simply just type in from the R console, or just using the print Y to get the values of this variable. It's pretty straightforward. And if you want to access whether your class of variables is numeric, is a character, or is logic. So basically, this function starts with is, will always give you true or false values. So besides the class, you can also use the is function to access the class of the variables. And when you have a very huge data set, if you are going to print my value, it will take forever to run. And also probably your computer will crash in the middle. So this is just showing, this means showing like when you have a 2 million row data frames and you print the whole data frame, it will take you like 30 minutes, 1 hour to respond. So what you can do is trying to use a head, like you just subtract the first 10 rows of your data frame to just get a peek on the data you have. So for example, here, I'm just trying to create a new vector. Here, for example, it's 100,000 values in X. And then we see that X is an integer, and from 1 to 100,000. So if you are going to print everything, I'm not going to do it right now. It will probably crash your computer. But if you put the head X, it will only pull out the first several elements for you to check. So you can check, okay, it's increasing from 1 to 3 all the way to 100,000. So this is how we can use the head to save some time. And if you want to inspect the structure of your variable, you can use the string. And for example, here X. It will show you, okay, it's a vector starting from 1 all the way to 100,000. And then the variable type is an integer. So basically the string will try to tell you the structures of the variables. What was that? So print will print everything. Head will only give you the first several elements. Yeah, for example, let me try a smaller number, okay? Like 100. So print X from 1 to 100, and if you use a head, so it will only give you the first several. So this is also useful for other variable types like a data frame, matrix, or list, not only just the vectors. And if you want to check how much memory allocated for your specific variable, you can use the object size with your variable names, and it will tell you like whether this is eating up your memory or not. And if you want to convert between the types, you can use the as point the variable types, like convert from the string to a numerical value, or from the numerical value to the string. So either way it should work. Just if you're really curious how to use it, you can just simply type in the command in here and see the results. And besides the variables, we also mentioned the workspace. So basically, it's just like the environment from here. We call it as a workspace, and you can use the following functions. First, every running R, they have a work directory. You can using the get work directory to know which location, which path you are on. And if you want to set to a different work locations, usually, for example, you are changing location from your own home project directory to your specific project directory, you can use the WD so that you can access those files easily instead of giving an error saying files not found or something. And if you want to list the names of existing variables and functions, you can use the ls command. This is pretty similar to the intro to Unix command line. The only difference is that we have a parenthesis denoting it's a variable. And if you want to clean the workplace, try to remove a variable, you can use the remove. Still, it's similar to the Unix command line. And here is the question. If you want to clean all the variables, what you should do? For example, here we have x, and y. How to remove them just at once. So basically, you can again check the help page of remove. It will say, okay, it has a list, a character vector naming objects to be removed. So what you need to do is that specify something to the list argument, and remember we just mentioned the ls will list all the variables in your directory, in your environment. So you can just run this one. So basically it will clean all the objects from the environment. Okay. You mean remove what? Brackets. Oh yeah, you need to specify what variables to be removed. Yeah. Yeah, ls will list all the variables. So there is a difference here. So again, if you not really sure, because I'm also not really sure about the input format of different functions, always use the question mark with the function name to check the documentations and see what's the expected input and what's the expected outcome. So that's about the variables. So variables defines what entities we have in the computing environment, and the operators defines what relationship between the variables we are going to have. For example, the very basic ones we learn from the primary school is plus, minus, times, or divide. And when we are later become more a senior, we learn there are some kind of a relationship operators, bigger than, greater than, equal, not equal. And if you have some courses in the computer science department, then you will learn this digital logic, what is and, or, not, XOR means means if they are the same, then this will give 0. If they are different, then this give 1. So basically, you have a lot of operators. Basically, they are going to work by 2 variables or 3 variables, describing the relationship. So here, the first operator is arithmetic operators. We learn it from very young age, and here's the formal definition. In R, you can use the plus sign, minus sign, times, the star as a times, and backslash as a divide to do the addition, subtraction, multiplication, or division. And if you want to do an exponential, you can use the double star, or simply use this hat symbol. And if you want to do the modulo or integer division, you use double percent percent symbol, or the percent symbol with a backslash. So here for vectors, you can consider like it's a collection of your variables. Like a variable is a scalar, just be one value, and the vectors is just like a collection of multiple values. So here we form like a one-dimensional vector. So you can do the subtraction to a constant. What it will do is try to delete or subtract the 2 from every element in the vector. So it's called the element-wise operations. So basically you can try with another operator like a +2, +5, ×5, etc. Try to see the output. So basically what it do is element-wise operations. So these are the arithmetic operators, but for matrix, they are in addition to the ones we talk about, it has the element-wise operation times or inverse. And we also know the matrix have some other advanced operators for the inner product, outer product. Simply use the percent, double percent with the times in between. So this will do the simple inner product multiplication for us. And if you want to do a matrix inverse, so basically you also need to consider the whole matrix as a whole component instead of just using the element-wise inverse. So this will just give you the solve math. This function will give you the inverse of the matrix. So I guess probably you can try to use the Euler equation using the arithmetic operators. Try to compute the left-hand side and see whether it's the same as the right-hand side. So I think probably I can just demo it here. It should be pretty easy. That we want to compute the left-hand side. It's just like translating the formula in the mathematics notation to a code notations. So it's we know it's E. It's exponential with 1, like the natural parameter we talked about just a minutes ago. And I is the imaginary number, and pi is the pi 3.14 and +1. So basically what we can translate is that we can use exponential 1. This will give us the 2.7. So, and the exponential of I is the imaginary number, and we want to times pi, right? So, and then we +1. So this is the left-hand side, I think. So if you run it, it will give you 0 plus this very small number, I. So ideally, this small number should be some rounding error. So basically, you can basically consider this small number is 0. So 0 plus 0i is actually 0. So which is the right-hand side, right? So basically, we can use R to verify the Euler's equation. So somebody like in the field, they said this equation is the most beautiful equation in the whole human history, because we involve all the constants like E, pi, the imaginary number is 1 and 0, and they have this nice workout. Everything will be cancelled out to be 0. So it's kind of like have some philosophy flavor behind. Like no matter how complicated the thing is, eventually they will add up to 0. So it's the same as the programming, right? Like no matter how complicated the program is, eventually it will be decomposed to the operators and also the variables we talked about today. Although it's boring. The operators for That's a good question. So square root, actually, we consider, yeah, every operator you can consider it as a function, but we are not going to talk about function today. The square root is actually square root, and so I think probably in this form you can see it's a function. Yeah. So square root 2. Yeah. So there are also some relational operators, like a comparison, when you are comparing like less than or greater than with the numerical values. And you can compare whether they are equal to each other or not equal to each other. So sometimes this is pretty useful in the flow control if you have the if-else statement. And here is actually what I want to mention before, like when we talk about the representation of the numbers in the computer, that if we compute the square root of 2 with a square and try to test whether the left-hand side value is the right-hand side value. So in theory, we know they should equal, right? The square root of 2 and then you make it a square. It should equals to 2. But in the computer, they don't think so because actually this is because there are some rounding errors. It's related to the precisions issue we have. Like if you calculate the difference between the left-hand side, right-hand side, you will see the values is not exactly 0, but it's a really small values. And this small value is we call the rounding error. So this is just a simple demonstration that when you have the numerical values, probably you shouldn't use the double equality sign to compare whether they are different or not, because they probably will essentially be the same. It's just like a very tiny difference resulted by the computer, not by the value itself. So the solution is that you can use the or equal. So basically what it does is trying to compute the difference between these two. And if there are threshold smaller than a threshold, then the R will think they are the same, because this smaller, this difference probably will be resulted by the computer itself, not the intrinsic difference between these two values. So basically, it's just like compute difference and then compared to a constant threshold, which is pretty small. All right, so if you are calculating this or equal between the square root 2 with the square and the 2, then you will see it's true. So they are the same. And there, besides the relational operators, there is also a membership operator. Like for example, belongs to, you can use the double percent symbol with the in, means A in B. So basically means A belongs to B or belongs to the group of B. So for example, here, I'm a single person, then the whole UCLA is a population. So basically I can see this double sign with the in to UCLA. So I'm a student at UCLA, so I belongs to, right? So this membership is sometimes useful when you are trying to check this value is in some set. Like for example, you want to check a particular gene, it's in the D genes list. Like you do the differential analysis and you came up with the D genes, and you want to see whether P53 is in that set. So basically, you can use the membership relation operator. And here is a question. We only talk about the belong to, but we don't talk about not belong to. So how to do that? So this is actually can be answered by the slice of logical operators like and, or, not. So what you need to do is that you simply, when you have the x belongs to y, you put a parenthesis of this operation and you add a not. So not is represented by this explanation arc. And besides that, you have the and or. So basically, it's really simple. And also, I think many other languages also use this this symbol. But in Python, we just use a or and. So Python is something else. But basically, the and, or not is trying to calculate that and means A and B both exist or both true, and or means A or B, either of them is true. And not is that, for example, not B means everything happens, but not running like overlapped with B. So this is for a single logical operators. But if you have a compound, for example, you have a vector, there are so many like a true or false. So you want to really see whether any of them are true or all of them are true. So you can use this compound function, the any or all. So any will return true if any of the values is true, and the all will return true if all the values is true. So this sometimes is pretty useful when you write the if-else statement, because the if condition, they actually expect the values to be just one single value, either it's true or not. If it's true, then we will run some command. When we run some code, if it's not true, we run the alternative code. So these two will be useful if if you want to map the whole set of true or false to just one single value. So using any or all. So here is another thing about the operator's precedence. So basically, it's about the priority for operators. For example, for the first one, we know that we should calculate the times first, and then calculate the class symbol second. So the value we got should be 7. But what about the next one? Like, okay, for the equality symbol, like a double equality, and also the and, which one to be computed first? Actually, for example, like if I just came across this issue, I don't really know. I just need to run the code and see the results. But here is like a small summary about the precedence rank. So the top to the bottom is the descending precedence, meaning the top have a higher priority to be computed first, and the bottom should have the lower priority. So basically, let's see this is a double equality. So it's kind of have higher priority than just a single and. So we should compute the left part first. So 1 equals to 2. I don't think so. So this will give the false, and the false and the 1 will give you the final results false. So does that make sense in some way? So basically, it's just like a computing order. And then if you feel confused about that, you can just run the code from our command line and see whether it's false or true. But the whole take-home point is that the priority matters. If you don't want to like have that trouble, you can use the parentheses to encapsulate the part you want to compute first. This is the most straightforward strategy you can do. For example, you want to compute the plus first, then you just use the 1 + 2 parentheses, and then compute the times 3 second. So this parentheses is pretty useful when you write those. You want to write the code in certain order. I think we can take another 10-minute break, and then after that we can talk about our objects. So far we have talked about the variables in R, and we also talked about the actions we can have on the variables, which is the operators. So now let's move on to some advanced R objects. So basically, you can think those operators and the variables are the building blocks for the R objects we are going to learn about. So here, it's listed the several common objects in R. So basically everything here is just, you can consider it as a container to hold your data, whether it's a vector, like a matrix, or a more higher dimensional data format for the array. And for the some other, like for the vector and the matrix array, they usually have the same type of data, like the class of variables should be the same. But we can also have some other type of format called a data frame, which shows like a tabular data form, but compared to the matrix, it can have different variable types, different variable class. And besides that, we can have some kind of unstructured data called the list. So which can be the same type of, like each element can be the same type of objects, or they can be different, or more like chaotically, it can be a list of lists. So which is like a nested list. So there are so many kind of combinations of the objects. So for the objects in R, we will mainly talk about the actions, like how to create such an object, how to index. So index means how we access part of the data, and then how we can do some kind of update, or how to destroy an object. So the destroy is pretty simple, right? Like we just talk about, we can use the remove function to totally get rid of the data. For example, some of the data frame is too memory demanding, so we can just remove it after using it. So the first one is called a vector, which is a very typical data frame, data type we are going to deal with. Sometimes I think it's my favorite object. Vector is not too complicated, but it's also like a big enough to hold my observational data. So how to create an empty vector? So again, like a vector is just like a one-dimensional data structure. Like each element is a variable type. We talk about, and how to create an empty vector is that we can use a vector function, specify the type, specify the length. So basically, it will, each of the values in the result will be either 0, false, or empty string, or equivalent of nothing. So the type can be numeric, complex, logical, or character. So these are what we mentioned before in the variables. So these are like the default values. If you run them, it will give you these values. Sometimes we want to create some meaningful vector, for example, a sequence vector from 1 to 10, 1, 2, 3, 4, 5, all the way to 10. So you can use this column to do that. Another thing is that you can use a seek function. So what it did, you can put a string like a from what point to the end point, from the start to the end, and by a step size. For example, step size of 2, or you can simply specify how long, like how many of the elements you want from the sequence. You can specify the length out. Again, all of the functions can put a question mark on the function name to get a detailed documentation. And if you want to manually create a vector, for example, you have several values in hand, you want to make them into a vector. So you can use this C function. So C is just like a concatenate, means concatenate, like the first letter of concatenate. So C 1, 2, 3. And for example, if you are a biologist, you measure the 2 groups of mice, the weight. So you can, after you collect the data, you can put them into a vector and then run a t-test in R, get the p-values, report the results, whether it's significant or not. So this is what can be done in R. And if you want to create a repetitive vector, like all the values is the same value, or it's like the same in some kind of a period of fashion. So you can use a rep. So for example, here, if you put the first argument put in rep can be either a single value or it can be a vector. So the next one is like how many times you want to repeat. For example, here I put the 1, 2, 5 vector, and then you put a 3. So which means it will give you a vector, final vector that have the 1 to 5 and repeated for 3 times. So you can also specify each, like how many times of each of the elements have the repeat. So repeat 1 for 3 times, repeat 2 for 3 times, etc., etc. And you can also specify, like, for example, in each of the elements, you want them to be different times of repetition. So you can repeat 1 for once, 2 for twice, 3 for 3 times, 4 for 4 times, etc. So basically, what you need to do is try to assign for each of the element in the vector, you assign another time vector, like how many times you want to repeat for each of the positions. So so this is for the how to create a new vector. And if you already have a vector, there are some kind of actions you can do. For example, you want to access the length, which is the number of elements in the vector. So you can use the length function. And here, I want you to note that the missing values, although it's missing, but they still count towards the length. So if your vector contains a missing value, it will not just like a length -1 to give you the final length. Instead, it will count everything in the vector. So missing value is just missing. Doesn't mean the value is missing, but doesn't mean the variable is missing, right? So it's still there. It's just that we don't know. And if you want to assign a new length to the existing vector, it has some kind of interesting behavior. For example, you already have a vector and you assign a shorter length. So basically, it will do some kind of a truncation. Like you have a length of 5, but you wanted it to be the first 3. So you actually just assign the length of the variable to be 3. So it will do the truncate here. And if you want to expand the vector, for example, from the current length to some bigger length, so basically what it will do is try to assign the NA values for the following, just add NA to the end. So sometimes it will be useful, like you expand it to a new value and then you sequentially add values to that. But yeah, this is what we can do with the length. So another thing I want to mention about the length is the number of elements in the vector. It doesn't mean the number of characters in the vector. For example, here we have 4 elements in vector, so the length will be 4. But if we want to count the number of characters within the vector, you probably need some advanced function like the nchar to give you like how many letters for each of the elements. But this is something different. So the point is the number of elements in the vector is 4, because each of the string here is just considered as a 1 element. So besides the length, a vector has also an attribute of a name. You can either specify the name when you first creating a vector by using the name and the value, name value pairs. So pretty standard naming conventions. If you already have the vector, but you want to assign the names to an existing vector, you can use the names function, simply names with a vector, and then assign the name vector here. So if you want to retrieve the names from a vector, you again like just use the names function. So you can get the names correspondingly. So I think one important topic is about the indexing. So basically here the indexing can be also referred as the subsetting or slicing. Basically, you don't want to access the whole part of data, but you want to only interested about the smaller portion of it. So how can you access them? So basically, you are going to use this operator, this square bracket operator. So you can have 4 different choices. The very first choice is you can put some positive numbers indicating like the position 1, position 2, like what what index of these positions. So here, I think one significant difference between R and other language like Python or C++ is that the index starts from 1 in R. But in Python, probably it starts from 0, right? When you want to access the first element in Python, you put the square bracket 0 to get it. But R is different, so this is a key message, key difference you should understand. So the difference is also understandable because R is developed by a group of statisticians. They are not the computer science people. They think naturally everything should start from 1. So it's the basic counting, right? You don't count from 0, you count from 1. Like if there is an event happening, you count as a 1. It's not count starting from 0. So this is intrinsic difference you should be aware about, especially for example, when you write the program, you should always have this in mind. Otherwise, you are have one position shifting, which will do a lot of damage to your research regression or research results accuracy. So besides the positive numbers, which just returns the slicer vector containing those elements in those locations, you can also put the negative numbers. So the negative numbers, again, is different from the Python, which will start it from the tail of the vector, right? But the negative numbers in R means you exclude them. You are not selecting them. So this is the negative number meaning. For example, here I give 2 examples. X is just like a vector of 5 elements. You can select 1, 3, 5, select the position 1, 3, and 5. Or you can exclude the position 2 and 4. So you will also end up with 1, 3, 5. And also you can input a logical vector either with the true or false value. The true will be returned and the false will not be will be just ignored. So for example, here I try to return the 1, 3, 5. So it will give me the position 1, 1, 3, 5 values. And besides that, if you are working with a named vector, you can also specify the vector containing these names. For example, here I assign names to X, and then we select the names we select the values based on the names. So this has some flavor as a Python dictionary, right? You have a K, you have a value. So the names here, it's actually served as some role of like a K. So this is a vector. And another thing you want to note is that the positive mixing, the positive and negative value is not allowed. If you run it, you probably see an error. And the missing indices will correspond to the missing values in the results. So for example, if you are input a NA value in the positive numbers in the index, you will always also have an NA value and the NA position in your results. And also for the, if you only have a vector of length 5, but somehow you input the 6 as the positive number 6 inside your vector, then it will not throw an error, but it will also have a missing value. So always remember to check the length and also the index you are choosing. The length should always be greater or equal than the index. And the non-integer indices, because we know the position 1, 3, and 5, basically those should be integers. If you are putting a non-integer index into that, it will be rounded towards 0. Like try to find the floor of the non-integer values. And here is also some kind of other useful functions. Try to find, for example, here which will try to return the location where the value is true, and which max. It's pretty straightforward. You are trying to find the position you achieve the minimum or you achieve the maximum value. So sometimes in the optimization algorithm, like you are running a EM algorithm or something, you really want to say, okay, at what position I achieve the maximum magnitude. So this is really useful in those statistical computings. And another thing I want to mention about the vector is the recycling. So basically, if you are working with if you run this code, you will see that the results will be determined by the longest vector. And if the results is not like these two vectors, they are not a multiply of length, and then you will see a warning. So I guess you can try to run it on your own. The idea behind is that in R, the shorter vectors will be recycled towards the longer vector to match them. So for example, in the very beginning, we compute the vectors addition with a constant value. So in reality, what R do is try to replicate for example, this is a scalar, it's the length of 1, but it tries to create a length of 5 vector, and each element is 1. So this is why we will see that it will do an element-wise addition, right? So basically, it's still like a computing 2 lengths of 5 elements, vectors, and for each of the elements, they are summing up. So this is for the element-wise addition. Why element addition looks like that? So this is I think it's also an interesting phenomenon in R, not seen in other languages. And if you have 2 vectors, how should you combine them into just one vector? You can use the C, which is we see before, like create a new vector. C stands for concatenate, and in the natural words, it means collect together with a chain. So I think it's a kind of like represents what we want to do, right? So you have 2 things, you want to collect them into one thing using a chain. So for example, here you can combine 2 vectors into one vector, or combine one vector and the scalar value into final one vector. So this will will give you the one vector, final one vector. And what we talked about before about vector is about the numerical values, but there are some kind of other values. For example, the strings and factors can be like a string and the factors can be the element of the vector. So if it is the case, then we have this like a string vector or to work with. So sometimes it's kind of a headache in Python, in R, to work with a string, because in Python you can use it very like handy functions, like a concatenate of the strings. You simply plus a plus sign, right? But in R, you need to have some functions to do that. For example, if you want to concatenate the 2 strings, you should use a paste. For example, the paste here, it will with a separator. I'll try to paste the first vector with the second vector with a hyphen in between. And sometimes you can also use the collapse, which means it will eventually try to collapse the values, collapse the factors with this little comma. So, and also the paste 0 difference between to the paste is that it doesn't contain the separator, so it will actually just concatenate two strings together. So there is no separators between these 2 strings. And besides that, you will see some functions like a to upper or to lower, which will change the cases of the string. So this might be helpful when you are dealing with the sequencing data. for example, TCGA, those like 4 letters of DNA sequence, but sometimes you want to convert all of them to the upper class to compare. So besides that, after you paste them together, for example, you have a hyphen in the middle, and then you can use a string split to actually split the data, split the string into 2 different parts. So this will be useful when you are working with some kind of metadata. You have the samples, and the sample names is coming from different sources, different tissue, different people. So they are collected with a separator. So you want to really split the whole string into different pieces. So the string split can be used. So we are not going to talk details about each of the function, but you can use the question mark with the function name to check the details under the examples there. So for the strings, the good thing is that it's very intuitive, but when you have a large set of the strings and many of the strings can be duplicated to each other. So actually in R, it will implicitly transform into factors. So as for example, in the metadata, we have the gender, right? The male, female, and we know that there are only two types of usually there are 2 types of those metadata. But the persons might be tens of thousands. So if you store those strings into the memory, you probably have a really like bigger memory requirement. But somehow you can convert it to factors that you are actually storing the integers, but each integer has a label, either it's male or female. So in this way, you can achieve some kind of memory efficiency. So here, how to create a factor is that you can use a factor function. Here is just like a small example. You have the male, female, and you factor them. So by default, the levels, which is just like which one ranks at first, which one ranks at second. So this is the so-called levels. It's corresponding to the integers it actually represents. So by default, the factor levels is assigned by alphabetical, like F is ahead of M, right? So F is smaller and M is bigger. So this is the alphabetical order. But you can actually manually design the order by yourself. Simply put a level order into the levels. Like they have an argument called levels. You can put the whatever orders you want. Male first or female second or female first and male second. So this one you can really control the order of the factors. And usually this factor is quite useful in data visualization. For example, if you want to represent, like if you're plotting the bar plot, you want to have some bars ahead of the other group of bars, you can just play with the factor levels to make it happen. So that's about the basic part, string, the vectors. And next part is about the arrays and matrix. I'm not sure how much time I have, but many things with matrix part. So the matrix and the arrays are pretty similar in terms of the data visualization, but arrays is a more advanced level. Like it can be expanded to be 3-dimensional, 4-dimensional, or higher dimensions. A matrix is only about 2 dimensions. So both of them are the rectangular data, which means they are pretty in good shape. They have the same number of rows, same number of columns, and so basically it's kind of like a giant Excel table. You have the values in those cells. So in fact, in reality, we only work with the matrix because we really work with the tabular data. So this workshop will also focus on the matrix part. So how to create a matrix? You simply use a matrix function. You input the vectors like fill into those cells and specify either n row or n column, like how many columns the matrix should have. And if you really want, you can input the dimensional names, try to assign the row names of the matrix and the column names of the matrix. So after that, you will get a it will spread out the vectors you input into the spreader a two-dimensional data format for you. So by default, the values will fill into the matrix by column wise. For example, here the vector is from 1 to 12, so it will fill in column by column. But you can control this behavior by specifying the argument by row to be true. So in that case, it will fill 1, 2, 3, and 4. So basically, it will fill in by the row fashion. And if you already have a matrix, you can access the dimensions using the dim. It will return two values, the number of rows and the number of columns. Or you can access either of them using the nrow, short for number of rows, number of columns. And if you want to reshape the matrix, for example, it's a 3x4 matrix, 3 rows, 4 columns, and you want to put it into 4x3. So you can actually specify, when you call the dimensional function, you can specify a new dimension. So that new dimension 1, new dimension 2. So here is a small example that previously we have 4x3. So if you specify 6-2, so it will convert it to be a 6-row, 2-column matrix. So this way you can reshape it. And if you want to access the row names and the column names, you can use the following functions. And if you want to update the names, simply just using row names matrix and specify a new vector. So you can actually change the names as you want. And for the matrix indexing and combine, it's pretty similar to vectors. So we can use a square brackets to denote an index, and we can still have those 4 options we did with the vectors. Those are also applicable here. It's just that we have 2 dimensions right now. So you probably need to specify, okay, what rows you want to keep and what columns you want to keep. Other than that, it's pretty much the same as the vector indexing. And if you want to keep all the dimensions, all of a dimension, for dimension 2, you want to keep all the rows or something, you just simply leave that corresponding index blank. So for example, here, you only specify the first row and leave the columns as blank. So it will by default meaning, okay, you want to extract the first row and all the values in the columns. So it will give you the final vector, the row vector of the first row. Again, you can do it as the same thing as try to keep all the rows, but just specifying what columns you want to extract. So if you want to combine a matrix, you can use the C-bind, which means the column bind. So it will bind concatenated 2 matrix by column. And if you use the R-bind, which means the row bind, you will concatenate the matrix as rows. So lastly, for the last data type we talk about, probably I can just leave this to tomorrow and talk about it along with the data frame, because these are 2 similar data types. And I guess we are running out of time. And yeah, I feel like those details probably is kind of too boring, but it's kind of important, especially if you want to be an expert in R. Those details really matters, especially when debugging, or you want to make your program running super fast. And I think mastering these details will be important. And okay, I will leave all the left things to tomorrow's discussion, data frame and the list, and we will continue tomorrow.